So we have an introduction last video. We talk about there is a shaft connecting into this piece of metal, and when it rotates, this piece of metal would actually vibrate. Okay, so we want to find equations to describe the system, typically the vibration of the system itself, right? Oh yeah. Nonetheless, if you remember, I was talking about z and x. The x itself is actually drop it out. I forget to talk about it. So the x itself is actually the small mass, which is the mass of the rod itself, the shaft itself, and e is the eccentricity of the thing. So what is it all about? So we'll just start off with using this format first. So we have to first understand the movement. So I believe I have explained how this movement would be in terms of this video. As you can see, the movement is that. And then, so we'll draw the FBD diagram, free body diagram, stating all necessary parameters, v, sign, length, etc. So I shall draw it out. So hold on, I think I'll draw along with you. So let's start. So if you remember, FBD describes all forces acting on the mass. So I call this mass M, capital M. Okay, and then we have another mass. We called it the M, small capital M, which is this shaft over here. Look at, we're actually doing in the 2D dimension. And then we also have, what do we have? We have the K, the spring constant, and then we have a damper. We call it Kx over here, and we have a Cx dot over here, if you remember. And then one important thing is that we have this X. This is the datum point and the middle of this piece of object. We call it so this is actually 0, okay, and then this is X. Okay, nonetheless, come to think of it, I think this is X. Okay, later I'll explain why. I may be wrong. Okay, so this is X, and then we have a if you were to zoom in this thing, okay, so maybe I should label all the stars over here. So we have, at first we draw the 1, we draw 2, we draw 3. Here we have this thing. Now we actually draw the part on the mat itself, okay, which is 6. So we're drawing on the so we have the shaft drawn out in this manner over here, and then we want to calculate the eccentricity of the system itself. Why is it eccentricity? Okay, by definition, the eccentricity is the distance between the axis of rotation and the center of gravity. Okay, so the axis of rotation is actually this axis, right? It's going, it's from here to here, so you rotate in this manner, right? But however, when it starts to spin a lot, and the center of gravity may actually shift. It may shift over here, so you may have some value of E, right? But nonetheless, the description itself is actually saying that this thing over here, it's E. It may actually move, when it starts to vibrate very violently, they actually move in this portion over here. So as you can see, if you look at this thing, there will be a certain eccentricity overall, okay, because it moves over here. So I repeat again, if you're talking, because as you may wonder why. So at first, this purple line is the original one, while when it vibrates, it actually moves with a certain distance, right? But still, when we are looking at the whole system, we are looking at the whole system over here. Okay, so there will be a certain eccentric shape. Okay, if you don't know what is it, you can just search Google. But this is what I want to convey. So this is E. While there will be a certain omega. Okay, there will be a certain angle. We call it omega t. In this case, the orientation of clockwise or anti-clockwise is okay. We are not talking about it anymore. We are not talking about it. And then we have to find this portion over here, right? If you were to ask me why, Okay, you will ask me why. Because e e e at this point should be the same as this point, right? Because as you say, they are radius of the circle itself, but no. This is why we actually say that this is e, because e itself is not the radius. Okay, this is nonetheless also not the radius. This is the motion caused by the e itself. So this is actually e cosine. If you were to talk about um right angle triangle, so this is actually e cosine omega t. Okay, so this is e cosine omega t. It is the forces caused by the movement. Okay, the movement is due to e. The movement is the moving distance is e. Alright, the moving distance is e. Okay, it actually move with a certain distance. So this is the angle itself. This describes how the vibration works. Okay, so yeah, as you can see, we are taking in reference with x over here. So the distance itself is x plus e cosine omega t, right? Because the whole thing will actually shift out. If you were to vibrate a lot, there will be certain eccentricity over here that may shift out. So there will be a certain different value of e cosine omega t. So this is why we use that. If you were to wonder why we don't use e, the value e as the whole system, because e is a force that is being represented by two vectors. Okay, so this is e. But however, if you are talking about one dimensional, okay, you have to look at the x or the y. So this is why I look at it. Because the force itself, although you can see it's the radius of the circle, but it's because they didn't describe much. So nonetheless, you have to really take note of this typical concept. I thought it was a pretty much important concept to piece out the pictures. And then with this, we also have to constrain a certain stuff, because as you can see, the vibration itself, okay, the vibration itself vibrate in 2D, right? Or maybe 3D. I mean, apparently 2D. So you'll move a little, in the x and the y direction. So we want to ensure that it vibrates in only the one directional. Okay, so far we talk about one directional. Talk about one direction. I don't know whether nonetheless we're talking about only one direction. Okay, one axis. Simply, so nonetheless we're also talking about this system. So what we're gonna do is actually to draw a roller. Okay, to draw a roller. So this roller will constrain the movement. Okay, will constrain the movement in terms of the x-axis. I mean in terms of the y-axis. So there will be only one vertical movement. Makes sense, right? So this wall constrains the vibration to one axis. Okay. So we have draw a free body diagram. So with this said, the next video will talk about summation of the moment, and then we have to find ways to simplify the equation again. So I'll see you in the next video.